Chapter 4, Section 1, Square Roots and Cube Roots, Master Level. So in this video we're going to look at how to determine the square root or cube root of a number using something called prime factorization. It is kind of tedious, I'll admit it, but it is in the curriculum. Basically what we're doing is we're trying to find the square root without relying on a square root button on our calculator. And maybe we're looking at a number that we can't tell just by looking at it whether or not it is a perfect square. Okay. Fortunately for you, you should know what prime factorization is. And once I review it, you'll probably think, oh yeah, I remember this. Okay. So what is the square root of 441? Is it even a perfect square? So I'm going to work down here and I'm going to try and break it down into prime factors only. And once I get a prime factor at the end of a tree branch, it's finished. I can't go any further. So 441, let's just start breaking it down. Well, I know it's not divisible by 2 because it's an odd number. Is it divisible by 3? Well, 4 plus 4 plus 1 is 9. So this is definitely divisible by 3. Okay. If you don't have a calculator, you can quickly do the long division. But if you divide it by 3, you get 147. Okay. Well, here, 3 is prime, so it's done. 147, well, okay, of course it's not even. Is it divisible by 3 again? Well, 1 plus 4 is 5. 5 plus 7 is 12. Okay, so that is divisible by 3. Okay. If you have a calculator, just divide it by 3. If you don't, just do the long division, and you will get 49. Again, 3 is prime, so this tree branch is done. How do you break down 49? Well, you should know your times tables. I would expect you to know that 49 is 7 times 7. And 7 is also prime. Okay. So this number has been completely broken down. It is done. So this means 441 can be expressed as 3 times 3 times 7 times 7. How can we tell whether or not it's a perfect square? Well, can we rearrange this into 2 equal groups? I think we can. This gives me 3 times 7, I'll just group those together, times 3 times 7. Well, that is 21 times 21. Both of those factors are the same. Therefore, this is a perfect square. So 441 is 21 times 21. Therefore, the square root is 21. Now, earlier in this problem, I mentioned long division. Let's say you don't have a calculator and you want to work it out by hand. So in the first step, I divided 441 by 3. How do we do that by hand? Let's demonstrate it up here. This takes me back to, I don't know, 3rd grade, 4th grade. I never forgot it. There we go. So 3 goes into 4 once. 1 times 3 is 3. And then I subtract. And then I bring down this 4. And then I just repeat. So 3 goes into 14 4 times. 4 times 3 is 12. And I subtract. And then I bring down this 1. 3 goes into 21 7 times. And there's my 147. 7 times 3 is 21. Subtract, and I get 0. There are no other numbers to be brought down. Therefore, this is my remainder. The remainder is 0. If your remainder is 0, it means that this, which we call the divisor, is a factor. If I got a remainder other than 1, it means that 3 would not be a factor of 441, but it is. What is the square root of 324? Right, so let's break that down. I can tell right away it's even. Okay, so I can divide off a factor of 2. However, if you always start with the smallest factors, the number left over here is always going to be a little bit bigger. So if you want to start with a bigger number, you might find that you're able to get to your result at the end a little faster. It's up to you. I noticed that the last two digits, 24 or 24, that is divisible by 4. Remember from our divisibility tests. So therefore, this is divisible by 4. 4 times 81. Okay. However, neither of these are prime, so I have to keep going. 4 is 2 times 2. Those are both prime, so those are done. 81. This is 9 times 9. Okay. Those are not prime, so we keep going. However, we actually have enough information to answer the question, but I want to finish the prime factorization tree. So 9 is 3 times 3, and this 9 is 3 times 3. So as soon as I get a prime number, the branch ends. Okay. So that means 324 can be thought of as 2 times 2 times 3 times 3 times 3 times 3. It is a perfect square if I can reorganize these into two equal groups. And I can do that. So this is 2 times 3 times 3 times 2 times 3 times 3. I have two equal groups, and each group, well, 2 times 3 times 3, that's 18. So this is 18 times 18. Therefore, it's a perfect square. So the square root of 324 is 18. Lastly, the number 405. Okay? It ends in a 5, so it's obvious it's divisible by 5. I get 81. 5 is prime, so that's done. And 81 is 9 times 9. I actually have enough to answer the question without doing this last level, but it does say prime factorization. Okay. So we are done. 405 can be thought of, written as 5 times 3 times 3 times 3. Uh-oh, we have a problem. There's no way I can rearrange this into two equal groups. I could have two groups of 3, each of them with two factors of 3, but I only have one factor of 5. So this doesn't work. What this means is 405 is not a perfect square. So the square root of 405, well, it's just the square root of 405. Okay? There's really not much we can do with it. However, if we do have a calculator with a square root button, we can approximate it. I know the square root of 400 is 20. So the square root of 405 is going to be just a little bit bigger. It's just going to be an ugly decimal. This is what we call an irrational number, because the decimal goes on forever and it does not repeat. How can we apply this method to cube roots as opposed to square roots? Well, the good news is it works exactly the same way. It's just at the end, instead of looking for two equal groups, we look for three equal groups. It's pretty simple. Let's see if we can determine the cube root of 729. Now I'm just going to pretend that I haven't seen that in a previous video, so I don't know what the answer is. Well, actually I do. Alright, let's break it down. Well, 729 is odd, so it is not divisible by 2. 7 plus 2 plus 9, that is 18. Therefore, that is divisible by 3. It's also divisible by 9. 3 is prime, so that one's done. If you have a calculator, you would get 243. Otherwise, you can get it from long division. So let's keep going. Again, not divisible by 2, of course, but 2 plus 4 is 6, plus 3 is 9. Okay, so that works. 9 is divisible by 3. Again, you could also divide it by 9. So you get 81. Whoop, keep that in blue. There we go. And from our times tables, turns out all we have is a bunch of 3s. So I'm only circling the prime numbers. So this means 729 can be broken down to 3 times 3 times 3 times 3 times 3 times 3. Okay? Can I create 3 equal groups? Yes, I can. And there we go. And each group is 9. So 729 is actually 9 times 9 times 9. I used a dot instead of the X symbol for times. It means the same thing. So therefore the cube root is 9. What is the cube root of 1,000? Well, obviously it's 10. Let's see if we can get that from prime factorization. This is pretty easy to break down. I know it's divisible by 10. It doesn't matter how you break these down. You can break them down however you want. Okay, 100. That could be 50 times 2 or 5 times 20. However you break it down is up to you. The fundamental theorem of arithmetic says that you will always get the same answer. Maybe just the numbers are in a different order. So I'm just circling the end of my tree branches. Those are all the prime numbers. So 1,000 is 2 times 5 times 5 times 2 times 2 times 5. Okay, so can I regroup them into 3 equal groups? 1, 2, 3. Yes, I can. Of course I can. We already know what the answer is supposed to be. So it better work. And there they are, rearranged. Each of these is 10. So 1,000 is the same as 10 times 10 times 10. I have 3 of them. So the cube root of 1,000 is 10. Like we didn't already know that. Lastly, the cube root of 2,744. Let's start breaking it down. I know it's divisible by 2, but I'm going to take off a little bit more because the last 2 digits, 4, 4, okay, those are divisible by 4. So I can pull off a 4, which gives me 686. Therefore, this is 2 times 2. So that part is done. Okay. Well, I know this is divisible by 2, okay, which gives me 343. Okay. Now, hopefully, you recognize this number, 343. That is a perfect cube. That can be broken down into 7 times 7 times 7. You saw that in a previous video. And 7 is prime. Okay. So this number up here is 2 times 2 times 2 times 7 times 7 times 7. Can I rearrange that into 3 equal groups? Yep. And each of these is 14. Right? So the cube root of 2744 is 14.